Hey guys, I'm here today with a special car that's just come onto the rear-wheel drive RC drift market. If you saw our live stream from our first round of February for our monthly comp series, then you might have seen me comping it already, but if you didn't, it's the new Redcat RDS. I have the ready-to-run version here, and I comped with it with no changes to performance, chassis parts, or electronics, aside from a Futaba 3PV remote and some small modifications to the stock knuckles. I'll show you footage from that in a bit, but today I'm not here to do an unboxing or anything like that. There's already plenty of videos on YouTube for that, including this one by Ninjona. Today I'm here to go over some of the more technical parts of the car for the guys in the hobby that already have some knowledge about RC drifting that are watching this car, and maybe answer some of the questions that they've been asking about it, as well as give some of my thoughts and suggestions on the car as ready to run for some of the newbies trying to decide if this is the right car for them to start with. I've been hearing the term competition spec chassis being used for this car, and I was a bit skeptical hearing that at first, but today I'm going to show you why that might not be too far off from the truth.
So here we have the car I used for the comp in its stock form. Shout out to East Bay Sliders Josh over at Delta RC in Antioch, California for hooking it up with one of his awesome new pit mats. He actually knocked me out during the comp, so it was a good challenge to put this car up against a fellow track owner. So like I said, one of the only chassis mods I did to the RDS before I comped with it was modified the front steering knuckles. From the factory, they come with this big brake caliper-like part on the knuckle that also acts as a lock stop. However, it's so thick that it limits the steering angle quite a bit. So to gain a bit of steering angle that I really needed for the way I like to drive, I cut the whole portion off the bottom of the knuckle. I initially left the top portion on that was acting like a stopper, and I was getting the steering to stop in a place that I liked, but for some reason it was inconsistent side to side, so eventually I trimmed the top off too. I also shaved a bit here on the lower control arm to lessen interference with the inside rim of the wheel. You could also counter this with bigger offset wheels or hexes, but I was working with what I had and what would fit the body I was using. Now I want to go over some points of the stock knuckles. There's a lot of holes for the steering link pickup, and the stock pickup point from a tuner standpoint isn't exactly the best spot for quick and parallel steering, but maybe due to the curved rod ends used, it works well, so I had left the pickup point the same as factory. Lots of adjustment can be something great for someone who knows how to set their car up, but for someone new trying to experiment with things, it can be a nightmare, so something to think about if you're new into the hobby jumping into this car. Might be best to leave that where it is until you have a stronger understanding about what moving points on the knuckle will do to the steering. I also wanted to point out on the factory knuckles for guys who have been deep into steering and suspension tuning is the kingpin inclination angle of the stock knuckles, or KPI. I drew a straight line through the bottom ball joint hole as straight as I could so you can see a slight misalignment compared to the top hole, so there is some KPI in the stock knuckles, giving you a bit of positive camber on the lead tire at full lock, as well as caster doing the same. And you can see the stock knuckles also have a bit of positive caster built into them that tilts the knuckle back towards the rear of the car a bit, similar to the stock YD2 SX, RX, and ZX knuckles. I considered trying those knuckles on here, but I had some other knuckles laying around that I tried instead. I'll probably be doing some videos in the future like Jordan over at Scale Science on some mods that I'll be doing to the car with parts that we have sitting around to try to get some more bolt-on performance out of the car. Another chassis mod that I did do that did affect the performance, but not anywhere past what the chassis should have had right out of the box, was shim this front shock tower a bit. I noticed that one of the upper arms was a bit bound up and found the shock tower was squeezing the inserts onto the pins a bit too much once I bolted it back on, so I tried shimming it a bit to sort of loosen the pins up without having excessive play in the caster spacers. Maybe since this car was brand new and all the plastic is still new, it'll loosen up once it's worn in a bit and I can take those shims back out. But I definitely wanted to make sure all the arms were nice and freely moving on the pins. I feel like that's a largely overlooked step in building a chassis kit that can really hinder the car's performance. While I had the shocks off to check the movement in the suspension arms, I did top them back off with oil to get any air out that might have gotten in there during the shipment process before I comped.
I did also add a 30mm fan I had extra onto it, along with a YD2 fan mount, part number Y2-304 SMA. During initial testing, I did find that the motor was getting a bit hot after half a Gens Ace Redline 4000 milliamp hour packed through it. Luckily, the factory motor plate already had a hole that was in a good enough spot for the YD2 fan mount. This would be a good time to mention that I was looking at the center brace and saw the two holes in it, so while I was testing the lower motor position,
I decided to try to screw a 30mm fan on it. It was a bit of a squeeze, and I had to thread one screw in a bit and then get the other screw threaded in and then tighten them both down, but I got them bolted on there. So if you decide to go low motor on the RDS, you already have a nice fan mount from the factory. If you use the high or mid motor mount, then you would utilize one of the clip-on mounts or the Y2-304 SMA YD2 fan mount like I used to cool the motor. And even on a stock motor and ESC setup, I'd suggest getting a fan to keep the motor cool to anyone picking this car up. So here's some of the footage of the car comping. Again, stock ESC, motor, gyro, servo, and shocks paired up to a 3PV with no chassis upgrades, and it was holding its own against Josh's heavily modified RMX 2.5. I did this in the stock upper motor layout. I did test all motor layouts, and I think I almost would have chosen the lower motor layout instead to comp with, but I wanted to keep everything just as it comes out of the box aside from the remote. So here's some of the pictures of the car on the scale. These are all with no body, the stock optional body post bumper with the foam bumper, and Yokomo body post with wrap-up next Flex MG magnetic mounts in the front. On the rear, I have top-line magnetic body mounts and the wrap-up next carbon brace with a Yokomo drift package rear bumper and Gen Ace Redline 4000 milliamp hour battery in the tray. I was also using Rev D 5-spoke wheels in the front and Overdose R-Tune CR Kawamis in the rear with Yokomo DRP tires instead of the stock wheel and tire combo. So this is the stock high motor layout. We have a 66% rear weight bias in the stock configuration. Here's Jordan's rear servo RDX for comparison. This is the mid upper motor layout. Notice we dropped about 30 grams of rear weight down to a 64% rear bias from 66 with the stock high motor layout. And lastly, the lower motor layout. We gained a little more rear weight from the motor swinging down closer to the gearbox, up to about 803 grams compared to 825 in the upper motor layout, but still retaining that 64% rear bias. The high motor will probably give you the best grip and forward speed at the cost of front responsiveness, and I could really feel this during the comp during transitions. I'm sure a different gyro could also help, but on the stock gyro, the transitions felt a bit slow for me for an aggressive competition car I preferred to drive with. You can see here I suffered a bit of transition speed and timing that I'm not so used to, but also lacked a bit of wheel speed to push me further outside after the jump. The mid-upper motor helped with the front response a bit, but I had a noticeable drop in speed coming out onto our straightaway. After I tested the lower motor position, I felt like it offered the best compromise in making the chassis responsive while keeping some of that weight on the rear for grip and speed. Like I always say, drifting is a balance, and you can't make one adjustment that will make one part of the car better without making another part worse, so it's all about finding what setup will work best for your style of driving.
I'm going to wrap this one up with some final thoughts on the RDS and some of the things that could maybe be improved on. Of course, it's not a perfect car, but for the price tag, I really think it's going to be a very competitive ready to run to the Yokomo and MST counterparts. There will be some initial setup to do out of the box, like doing the gyro endpoints, which if you buy a car like this in person from our shop, we're always willing to help you out with getting started with the initial setup on the car. But if you're someone just doing this on your own with no one else in the hobby to help you and no hobby shops close to you with experience with this stuff, then it might be a little harder to have a car like this versus something like the MST that's preset and tested out of the box before you get it. So out of the box functionality would be one of my first complaints. The chassis was set up for a Redcat's unlicensed body, which I immediately took off in favor of my D-Like S14, which is a 200mm body front and rear. Most people would say that should be a wide enough body to run for drifting, but Redcat's body is a whopping 205mm front and rear, and the chassis is set up perfectly for this body with good fitment out of the box. This creates problems with anyone who picks this car up wanting to run a body with anything less than a 205mm width without somewhat major suspension and alignment changes that could drastically affect the way that this car handles. While adjusting the motor for different pinion sizes, I noticed the slot on the carbon motor plate had some rough machining, so I really had to work the motor back and forth to get the slot cleared out so I could adjust the pinion mesh on the motor properly. Not a big deal for most ready-to-run users that won't be changing pinions out, but something I experienced. While I was installing the front magnetic body mounts, it seemed like the spacing of the body post holes was slightly off from the spacing on my YD2s and MC1. Not sure if body post spacing has been standardized on 10 scale on-road cars, but the RDS post spacing was definitely different than what I had my body set up for, so the magnet stretched the post slightly apart a bit when I put my S14 body on. Before I even drove the car, I had the differential out of it, and I noticed one of the bearings had some flat spots on the outer race, almost like someone hit it with a Dremel a few times. Probably wouldn't affect anything, but that was just a sign of poor craftsmanship to me. I threw it back in the car anyways. The whole point of me taking the diff out was to see if anything YD2 would fit in it. As of right now, the YD2 differentials would not fit, but I'm trying to work on a way to try to make them fit inside that I would go over in a future video. The stock gray ball cups seem to be really low quality. A few of them were way too tight and didn't allow for the suspension to move as freely as it should, so I squeezed them a bit with some pliers to try to loosen them up, which worked a little too well on a few to where you could twist the cups off the balls with little effort. On most of the links, the turnbuckle was basically fused to the threads on the inside of the ball cup, so if you go to adjust any of the links, you'll turn them so hard that the ball cups pop off the balls while you're trying to adjust them, which makes the links very hard to adjust until you work the turnbuckle through the threads on the ball cup and loosen them all up first. The ball studs don't have your standard hex hole in the top of them, so you have to pop the cups off and unscrew them with a 5.5mm driver, and in turn the ball cups don't have an access hole in the top since you wouldn't be able to unscrew the balls with a driver anyways. Seems like the industry standard for hobby grade ball studs and cups are to be able to use a regular driver to install them. I guess not on these ones. The last gripe I have with the chassis side of things is with the direct steering system, and it's a couple of things. The horn seems to be pretty tight when the car is off with barely any play, but when I have the car on, it seems like there's a bit of play in the horn when I move it back and forth. This can be troublesome when trying to center the steering system. The steering plate used for adjusting Ackerman can be easily accessed through the top of the bulkhead through these two holes, but since it's slotted with no teeth to hold it in one spot, I'm pretty sure you could tighten it down unevenly if you don't line up the mark side to side or just pull it all the way forward or back. Also, since it's slotted, if you hit something hard enough and the screws aren't really cranked down super tight, I'm sure the plate could move and cause changes in your alignment. I also wondered why it was designed to steer across a flat axis with no forward tilt like the Rhino Racing DDSS and the Rev D bell crank. Both of these are tilted forward or adjustable for a reason, and that's to limit some of the bump steer full lock, but some people like to tune with some bump steer, so I guess it's a personal preference point. Complaints with the electronics are pretty much whatever, since most people know you're not getting much with an RTR, but I feel like these are worth mentioning. The stock motor is not labeled with A, B, C anywhere. I had to reclock the motor position in a bit to move the wires down to clear my rear window, and I figure many other people will have to as well if they decide to put a different body on it, so I ended up having to unplug the motor wires to move them around. Luckily, I looked at where the A, B, and C wires were going to from the ESC before I unplugged anything, so if you're watching this trying to figure out which wires are which on the motor, here's this. The gyro comes from the factory in the AVCS mode. I tried this mode to experience the car in the out-of-the-box configuration and really couldn't get the car to drift comfortably. It definitely felt like an AVCS mode where you have to steer into the turn. I switched it to normal mode and set the gain, and I was drifting it flawlessly after. Again, maybe it's personal preference. Maybe you can drift it better on AVCS. The servo has a bit of visible hunting even with the gain on the lower end, but I'm not expecting too much out of RTR electronics, and I almost expect it on RTR setups. This can be a bit difficult to dial back if you're using the stock remote with no channel 3 adjustment and adjusting gain directly on the onboard gain dial. Lastly, but one of the most important things I noticed about the stock electronics was the motor getting hot half a battery pack in. I hit it with a temp gun and it came in at 131 degrees. That's usually where I kick my fans on my AccuVants on my MC1. Arguably, you could probably go higher than that without damaging the magnets in the motor, but that's still pretty hot for a box stock RTR setup with less than a full battery pack of runtime. Now I have a few upgrade parts to suggest, so Shane, if you're watching this, maybe you get some ideas for new product development. An aluminum motor plate, mainly to get rid of the machining for the adjustment slot in the carbon fiber. A heatsink design built in would also help dissipate some of that motor heat, and it's something already in production by the other major RC drift manufacturers. An aluminum servo horn and an aluminum spline steering plate. Having that carbon plate mated to the plastic horn, it's able to flex up and down a bit, and I already explained the problem with the slotted steering plate. A ball diff that fits in the RDS gearbox. Not sure if Redcat has any ball diffs in any production cars, but it might be something some people want for their RDS to be able to easily adjust differential lock, especially now that my ball diff video is out here. aluminum shock collars and caps. When I initially heard aluminum shock bodies on a $400 ready to run, I was excited, but then a bit disappointed when the car showed up and I saw plastic caps and collars. On most of this stuff though, I get it, it's for cost effectiveness, but separate upgrade parts down the road would be nice. My last suggestion would be a threaded aluminum rear shock tower. I have both the aluminum and carbon rear shock towers on my YD2s, and I can tell you the aluminum one that's threaded for the Camberlink ball stud is much more enjoyable to tune roll center with than having to get a nut on the backside of the carbon one to secure the ball to it. Option part though, most RTR guys don't have a clue what roll center is anyways, and really once you know where you want your roll center, you're probably not going to be changing it much. Despite all of this, I really think Shane and Redcat have something special for them in the rear-wheel drive RC drift community in their hands, and I can understand why some of the decisions that were made for the car were made. After a few days with the car, I can really believe it when people say competition spec chassis when they mention the RDS. Granted, it's not any $1,000 high-end chassis from Japan, but for what you put into it compared to the other RTRs, you get a lot more out of it. There's apparently 2 hop-ups in production for this chassis that haven't been released yet, and I'm excited to see what else is in store for this car later on. I'll probably be doing a short series on the RDS, doing some notable upgrades with stuff we have sitting around the shop, as well as going over some of the stuff from other cars that may fit on the chassis. So stay tuned for more, and I'll see you guys on the next one.